Hello everyone, welcome to the next edition of Raku Reviews. And today we're looking at the Perl Weekly Challenge 81 and task number 1, which is called Common Base String. Let's look at the task first, and the task is: you are given two strings A and B. Write a script to find out common base strings in A and B. A substring of string S is called base string if repeated concatenation of the substring results in the string. So there are two strings, and you see, so the first string can be composed out of two parts, A, B, C, D, and actually this part can also be used to create the second string, A, B, C, D, A, B, C, D, A, B, C, D, A, B, C, D, but you also can just repeat the first string twice to get the second string. So these are the two possible results. And example 2, A, and the only common string here is just one character, A, because here you have two characters and here you have three repetitions of the same substring. Right, so that's the task, and let's look at the solutions in the Raku programming language. So the first solution, let me once again start with my solution. Here is the solution. So what I'm doing here, so the whole program is the main function. I'm accepting two strings from the command line, and the next step, what I do, I just want to make sure that the first string is always shorter than the second one. It's not at least longer. If it is, I just swap these. So this is one of the ways to swap the strings in Raku. And after that, just completely straightforward solution. So you start with the substring of one character and you increment this. So this is where I just try to find all the substrings that start at the shortest string at the first position. You see, so it's always start at the first position and is n characters long. But I don't test all the strings because we know that those small strings should be when concatenated should be generating the original strings A and B. So it means that this string C appears exactly integer number of times in either A or B. So this is the check where I check that it is possible to have the integer division result after dividing by this n, and if it's not the case for both strings, then I continue with other attempts. So at this point here, we know for sure that if we will split this string A by strings containing n characters, then we will be able to reproduce the string A and, at least the length of the string A. And also, if we will repeat sometimes, we will get the length of the second string. But that's not the final test, because we have to make sure that basically we generate the string that we want. So this C equals A, right? So we make sure that this small substring is actually can be repeated to get the original string, and the same for the second string. So if we will repeat C the given number of times, and this what I selected is always an integer, as well as this value is always integer, and if it's equals to B and this one is A, then we can print the result. So let's just run it. Well, actually you already see the result, but Raku it's a bit too much. Right. So here's the result. So this string is this part, and this string is that part, right? So there are two parts in the solution, two substrings. Okay, Arne Sommer, Raku number 1. Again, we have the same thing as just in the previous solution, and the same thing as always with Arne solution. So the whole body here is the main function. We have string A with at least one character, string B with at least one character, and there's the mode to see the details of the solution. So different characters in A and B, unless Arne immediately checks if there are at least common characters, right? So if there are, so this is where we split into characters, take unique, then sort and join. So we get some string containing all the characters only one time. They appear in this string, in the first string, and if the characters are exactly the same, if these substrings are the same, this is the first test to basically allow all the rest, because otherwise we know for sure that we will not be able to find the base string, right? So different characters in A and B. Right, so this is the number of characters, the length of the string, unique characters, combine unique elements, the number of unique characters, and this is probably the result, right? Because we are going to print it. Right, so so we start the minimum. Okay, so yeah, I started with 1, but this solution starts with this unique. So basically, there's no need to scan for less characters, for few characters in the substring. 2, the maximum is the minimum of the lengths. That's right. So this is the length of the substring. And here again, so yeah, definitely we have to start with the first characters, position number 0. Here's the substring. We can see it if the -v flag is on. And after that, so we append this solution to the results if basically the repetition gives us the original strings, right? Yeah, so very, very straightforward. Well, yeah, I mean, it's really a good thing. Arne, Raku, 1, and these 2. Right, so the result is the same, just printed differently. Good. The next solution, Jan Krnavek, Raku number 1. Here is the solution again, as in many solutions by this author. So I really like there are 2 main functions, multi-main versions of the same main function. One for just when you provide some input, and another one for just testing. There are some test cases which we can just run with -- test. Okay, and the cone-based strings of A and B. So A and B, this is different type of solution. The regular expressions are used here. I also thought of regular expressions, but yeah, I didn't come up with the nice solution, but it looks like this solution is quite interesting. So we match. So yeah, see, so match. Yeah, by the way, yeah, you not necessarily need the tilde. You can just call the match method on the object, well, the string in this case. So match, and so yeah, here it ends, right? I didn't actually quite realize that you can add these modifiers, actually add verbs to the end as the second parameter, because in the standard smart match form of matching against regular expressions, you have to put it before the opening slash. So the regular expression, the regex starts here, right? It is tied to the beginning of the line with this caret, and also to the end of the line, and inside basically what we have is a number of characters, at least one of them, and after that this $0 is the thing captured with these parentheses, right? So, and we expect some number of repetitions of that thing, or none, right, because of the star. And after that, what we do here is there's this code block inside the regex with another regex inside the code block within the regex within the code block within the program. So with $0, so if this $0 exists, right, so if we found something to match here, well, I believe it happens only if this regex matches, right? That's correct. So if we already discovered this string which can generate $A, well, actually it can be the whole $A, right? If there's no repetition, so then basically this captures the whole string. So if this exists, then we want to match against B, and the regex to match against is at the beginning, at the end we fix it, and inside there's this $_ repeated at least once, right? So, or maybe more than once. I don't quite understand these quotes, but probably yeah, this $_ so yeah, after this with instruction, the $0 becomes a topic, which is $_, and yeah, then we have this regular expression, right, regex. Okay, after that, so here it ends, exhaustive. That means that we will find, I don't know why do we need this? Right, so probably it's kind of because we want to explore, yeah, so we want to explore all the possibilities. So like, for example, in the first example, where we have these things like 2 different results, like 1 and 2, right? So yeah, we want probably to find all of them, and that's it. So and after that, so you just take, what do you take? So you take this the match object, you map all those items inside it to basically, yeah, you take the string out of that. Probably you can just use the tilde and the star instead of that, but nevertheless, let's try this one. Raku 1 bash Raku 1. Well, yeah, we can run the test definitely, but probably it's more interesting to run this one. Right, so we found this, and yeah, different order, but that's not important. So yeah, the first match was found, like the whole string was matched, and this was an empty thing. And after that, yeah, we found another really interesting solution. The next solution is by Kang-min Liu, Raku number 1. So we've got main function with two strings, common base string, which just, oh, nice. That's the union, right? And docs, I wonder what is the ASCII version of this character. Where is it? So yeah, this is the thing. Right. So it's an intersection, right? Not a union. Intersection. Base string of A, base string of B, and right. So I've got the idea. So we try to find all the possibilities to find the base string for each of these strings, and after that we try to find common elements there. Dot keys, right? Okay, so we grab all the indices starting from 1. If this is divisible by n, and yeah, I think double % would fit here, right, instead of this. And the substring repeated this number of times, okay, yeah, equals the string, then we take this substring, yeah. So we take substring, we call this substring method twice, I think, in the case of success. But nevertheless, so yeah, after this call, we've got all the substrings that can give you this string. In the worst case, it will be just one element with the string itself, right? And the same for this. And after that, we find this intersection, and that's it. Right. Raku Raku 1 Raku. So we need something to pass. Yeah, so it gives exactly the same result. And these are the keys, right? So what is the... So what this... Maybe I want just to see what this function returns. So return this one and return grab. So this is my R is DDR return, right? So that's what I want to know. And I need the strings Raku T Raku this. Yeah, so this is the sequence, and this is the sequence for the second string, and yeah, we immediately see these sequences which will give the result after the intersection, after intersect those two. Okay. The only thing you see, so it appears in different order, all right, than here. I wonder why, because yeah, the order is not defined here. Okay, good. Going next. Mark Anderson, Raku number 1. So common base strings, right? So there are already built-in values in the string. There's another sub. So sort keys base string of string 1. Oh, yeah, here we have this alternative version of this intersection set operator. So yeah, basically we do kind of the same, but the function for getting the base string is different. So we take either the string, we always take the string, that's correct. And so there are no like, still we have these keys. Why do we need that? What if we will just omit this? What we'll get in the result? We've got a set, right? So, okay, yeah, so because we don't need these, but probably we can just put it here, right? Yeah, so that's the version. Okay, so here again we've got the, so we take the whole screen and we take this dollar, and so yeah, we take basically this captured value. Again, we see this exhaustive adverb, and we match the string against this regular expression. But we right. So we do not tie it to the end of the line, but actually we do not tie it to the beginning of the line. I wonder if, for example, you have this B letter in the beginning, will it change? So let's run this solution also in our test environment. So these are the tests. So we can run this Raku T. That's no doubt. But what if, for example, yeah, like which letter we have, like P? No. Yeah, but this one is incorrect, I believe, right? Because, yeah, because we have to tie it here. We don't have to tie it to the end, but we definitely have to start. We always have to start, right? So that's the solution. Okay, interesting. Yeah, I like that as well. Next solution, Markus Holzer. So unit submain, the whole program is here. You see, so there are no names for these. That's a bit strange, but fine, because we take those from the... okay, so that's nice, that's interesting. So yeah, because we min max, so string A is... really? So this is how we do that. So see, so in this args array, we've got two strings, right? Because we demand this function to accept only two arguments. Not more than, not less, not fewer. And we sort this and we find the minimum, but the minimum is just based on this criteria. And after that, we take those minimum, right? Wow, that's cool. That's a really interesting pattern. I really like that. Okay, so we determine that $A is the shorter string, or at least the string which is not longer than B. Custom operator, just fun. That's fun. And here's the main job happens, and so we say for grab, what do we grab? We grab this, yeah, so this triangle reduction operator with the string concatenation inside. We split those, yeah, so yeah, we split the first string to characters, and we create strings with increasing lengths. Again, we are still tied to the beginning of the string, right? So because, yeah, we have the first letter, then the fifth and the second, the first, second, and third, and so on, including the whole string definitely as the last element here. And we grab all of these divisible by this one, right? By something, or something actually, the current element here in the loop. But all, so that's cool, that's cool. So these constructions does the job just to make sure that both A and B are divisible by the string, and the divisibility operator is defined here. It's defined for strings and returns the Boolean value. So given if, so first we want to divide the number of characters in the first string by the number of characters in the second string, right? $N, $D. And if the denominator is 1 and numerator is the result of the division, right? So by making sure this is 1, we make sure that this result is an integer, right? So we repeat the string, the substring, the given number of times, and if the result, yeah, if we can do that, we try to compare this repetition with the original string, right? And that's it. Okay, nice, really nice. And let's run it. Raku, Markus Holzer, Raku Ch1, and some things like this, right? yeah, this is the correct result. Good. Okay, going next solution is Simon Proctor. So here we are. There are a couple of strings from the command line. We say everything for the keys of this, again, intersection, and the intersection comes from two parts. Well, it's formed after getting the roots of both strings, and this is it. So there's regex exhaustive one. So we start at the beginning. We want some characters which are then, this substring is repeated number of times, maybe 0 times, until the end of the line, and we then convert it to a string, and that's, yeah. Right, so, okay, let's run it. Raku, Simon, Proctor, Raku, Ch1, the things, Raku, that's correct. Okay, going next, Athanasius, Raku number 1. So here it is. So yeah, so there are some explanations. So first we find the common lengths as an intersection thing, and then common bases, again basically the same code, right? So but just different function. So where do we start? Where do we start? Yeah, we start immediately here. Common, let's look at this. Find base strings. Find base strings is the function that so we scan the lengths for lengths. What is lengths? Where is it? So yeah, it's an array. Common length. Okay, so yeah. So okay, so yeah, we find the possible ways to divide the string, and we only scan those possible lengths which will fit both strings, right? So where we can find, yeah, so yeah, the substring should match the initial condition, right? And we only scan those lengths. Okay, so we scan those possible lengths, and so yeah, we take the substring of that length, we repeat this a number of times, and we check if the string gives us the original string, then we collect this, and that's the result. And after that we do the same for the second string, and then just using this nice Unicode operator, we just intersect those two sets, take the keys of it, and print it, well, sorted also. And here's the function to find the divisors. So yeah, basically, the divisors are obviously 1 and the lengths, right? So this integer is the lengths, and we try to find everything in between, but it's tricky here. So first of all, let's see, so this is the square root, and after that, so if it's divisible, we take it, but we also try to take the number lengths divided by this number, right? So yeah, that's why we don't have to scan the whole array. Good. Okay, let's run this solution. Raku, Athanasius, Raku, Ch1, and these, no, not these, but these. Right, so here they are. Good. Next solution, Colin Crain. Here's the solution, and yeah, there are some defaults. This is, I believe, like $A is twice as long as $B. What we do, we use bags here. Okay, find base strings, convert explicitly to bag, and if exists the bag A for okay, so yeah, we find base strings in A, we find base strings in B, and then we just in the loop try to find those which are common. So yeah, this is the intersection basically, right, altogether. And the base strings, 1, 2, 3 lines between the functions. So it takes the string, it scans the range of the indices, right, starting from the first index, grab chars if this is divisible, right, if the current number is divisible, if the original length is divisible by the current number in this loop, and if so, then we basically divide. Yeah, if we can divide, we divide, and And we scan all over those lengths, right? So these are like common, well, these are the possible lengths that we can use. We basically use these lengths, make the substring of that, and collect the result. If so, see, so here's the explicit Boolean conversion. If this, okay, so there's no X operator here, but there's a regular expression with the plus. So we try to repeat this some integer number of times, but not 0, and collect that. Okay, that's nice. So Raku, Colin Crain, Raku, 1. Right, the result is, and maybe with the default. Okay, so these are the possible substrings for those A repeated. Right, Jaldhar Vyas, Raku 1. So again, we take a couple of strings. I don't know why we need these stars here. Smaller, larger. So we want to make sure the first string is always shorter. If not, we swap them. Right. Basically, we just assign smaller and larger to A and B, to either A and B or to B and A. And for smaller chars, so we scan the indices in the possible indices in the smaller string, and if it's divisible, if the length is divisible by the current number, larger, smaller, we take the substring, larger, we globally replace the substring with nothing, right? And okay, so that's another way. So we replace everything that we can. Actually, this is not exhaustive, so it will not overlap. So we just replace all occurrences. Potentially they are located next to each other if the string is, if we found the correct substring. If not, something is left after these replacements, and if nothing was left, then we take the substring, and after that, we sort and print it. Right, Raku, Jaldhar, Raku, 1 substrings. That's correct. Julio de Castro, Raku 1. That's cool. Well, at least it looks cool. I believe this also works. So what we do, we map the input strings, and after that we grab those which give us the Boolean true, right? So star. We then stringify everything, and we keep the unique values, and after that we say, well, actually we can put dot say here instead of this, so that it's one continuous line. Okay, so let's look at the regex here. So so basically what we do, we map the original string to, and we take these. Okay, so we, for each original string, we try to find the parts which you can repeat to get the original string, right? So after that, basically you will have this repeated string. Wait, but it's, will it give us all the combinations? Raku, Juli, or Raku 1, and this one, for example. Yeah, really nice. I didn't quite understand why we get, like, where's the global match here? Ooh, okay, let's I like the solution, and I'd like to learn more about this. So Raku T, and we need some input data like here, right? So here there are 2, right? So if we run this, we've got this, but actually, now I understand. So actually it just maps all the input values, and it tries to find the substring which generates, after being repeated a few times, the original string, but actually it doesn't check the second string, right? So if, for example, we'll break this one, so it cannot be created by repetition, then we still find this one, right? Yes, so we found the string from that substring, right? All right, for example, if we'll like 7 and 7 here, so it will give us this string. Okay, right. Okay, nevertheless, going next, the next solution by Lauren Rosenfeld. No, there's no solution here. Mohammad Anwar, Raku number 1. So there's the main function, which takes a couple of strings with some default values, string 1 and string 2 with actually with dash, it's named parameter, and after that the common base string function is called, and no indentation here for some reason. So the string in the input, another string in input, and the output is also a string. Length, we get lengths of both strings, and if the first string is longer, then we basically swap the strings, right? Minimum string is well, we do not swap it, but we just take into account that this mean size and mean string is that value. After that, the common base string, so we scan the minimum string range of characters for the minimum string. I is an index, and base string is the substring from the min string, from 0 up to that. Push this string to if it's negative indentation. So if this string, basically if either, but actually why either? We should like it should be and here, if I'm correct. Wait, if the string is base string repeated twice, why twice? Okay, let's run that. So Raku, Mohammad Anwar, Raku 1, and there are some defaults built in. All right, that's correct. But what if this one, string 1 is, string 2 is. Still it works. Wow, really? But but why? So okay, wait. Yoo-hoo, we got it. So basically, first of all, this one should be ampersand, right? If I understand that correctly, so that like this string cannot be the base string for that one. And this one, why is it 2? It should be just as much as possible to get the whole string. Maybe I didn't get, so challenges 80, which one? Common base string 81, and where is it? A string, write a script to find all common base string. So it's common, so it should be in both. Right. Okay, nevertheless, let's go next and Myoungjin Jeon, Raku 1. So what we have here, the unfold and golfified version. Maybe let's look here. So what we have here, we have some strings, right? There should be exactly 2, and great common divisor of the of those lengths, string lengths, right? That's cool. After that, we map that to a pointy block, basically an anonymous function with k as a sigil-less parameter. After that, we take the substring from the first string. We take the substring. So we map those potential greatest common divisors, right? And we so I would try to split. But wait, substring with one argument. What is it? What is it? Substr. If this only one, so it's so right, really, so basically, wow. Okay, so that's right. So if this is 6, so we get this basically up to the 6 character, right? 0, 1, 2, 3, 4, 5. Wait. No, from the 6 character, right? So it's actually. For us in this task, it doesn't matter actually if do we start from the beginning or do we start from some central, right? It doesn't matter which word we are using, right? Next, a possible base string, right? Next, if, so we skip the loop if any of these is not if the position of the string is not like the expected position, if we can split this string into pieces, right, with this given k. And after that we take this, right, as the last computed value in this block, and then we, well, that's wise, and especially if it works. Raku Jeon Raku Jeon Raku. Let's give this to this program. Oops. Why? Yeah, like here's another example. Let's remove these and add these, so it works. Perl Raku. Of course, those do not work because it was an incorrect input, right? So now, wow, that's cool. And maybe write this. Yeah. Okay. Yeah, that's cool. That's really cool. Yeah. So it's not a standard solution, but it looks good. The next solution, Roger Bell West, Raku number 1. So there are a few test cases, and right. So there's there are two functions, BS and CBS, right? So base string and common base string. I don't know, base only one, base, yeah. But basically, what we do here in common base string. So this base string is only. No, yeah, so we use these base strings. So yeah, so we take the string, we determine the base strings, right? So how do we do that? So we take the length, we scan the string, so that, yeah, we scan kind of half of the string. And if this is an integer, right? If the result of division is an integer, then we fill this hash with the position and the index, right, with the number of and the index, and after that we just using these data, using this information, we just check if the string can be rebuilt using this part, and we collect the result. Okay, so after that we get the array. So right, so we then map this array for all the strings. So yeah, so this is the base strings for, okay, so we call this base BS function for all the input strings from here, right? Then we create the set hash, and right, and basically, yeah, so intersection here again, and basically I would try to find those, and basically the intersection of those elements in the BSS, right? And those elements actually are already erased. And after that, we take the keys. We saw this a few times already. Raku, Roger, Bell, West, Raku, Jeon. Which one to take? I believe this one. Oh, yeah. So our input was ignored, but actually this is the same example here. Okay, so it works. And there's no solution here anymore. No, wait, sorry. Ulrich Rieke is the next solution, the final solution in this list. So we take the strings from the command line, we determine the base strings, and then we use the intersection set operator. So we see, so we convert explicitly this to set, and actually notice that all that happens inside the double quoted string. So this is the interpolation. And find base strings is the function which takes the string and get the lengths, find divisors of that by finding all numbers which are for which it is possible to divide the input number and basically the lengths, right, by the given number. So okay, so here are the list of integers, and we take those substrings, we multiply this, well, before we multiply, we determine how many times we have to repeat the string, and yeah, basically this is the multiplication. You see, so it's XX this time. So it's list list repetition, or what is it? List repetition operator, that's correct. And after that we take this, if the string, yeah, being repeated gives us the result. Okay, we can run this. Raku Ulrich Rieke, Raku, Ch1. Right, that's correct. Now, that was the last solution in this list of the Raku solutions of week number 88, and we were solving the task of getting the common base strings of a couple of strings.